So for too long, rules
Like it could be a throttle.
Why are you making a plane?
Yeah, good question. Let's see.
Yeah, so I talked to the composite shop and I've run the numbers for the engineering hours, and it seems like to continue forward with the Skytron design, it's going to cost about $20 million.
So welcome everyone. For those of you who don't know me, I'm Greg Mercer.
2 years ago,
Totally
I sold the
transparent.
company that I've been building over the last
Start to
decade.
finish.
Well, I'm Greg Mercer. I guess a couple people mentioned Jungle Scout.
I'm on my way to flight school right now, and there's such an incredible stark difference between the technology that's available in the rest of our lives, and then I get in these old rickety planes that haven't really changed since the 1970s. Commercial airliners are by far the safest mode of transportation. After that, it's something like driving your own car, which is much more dangerous than commercial airliners. And below that are things like general aviation on your private airplanes or driving around on a motorcycle. 4 out of 5 crashes are caused by human error. Not because pilots are bad, but because they're being asked to do way too much. And that's when I realized this isn't a pilot problem, it's a design problem.
A small plane crash.
A small plane.
A small plane.
A plane crash.
A pilot lost control.
Loss of control.
Was loss of control by the pilot.
The accident could have been prevented.
Several errors the board's aviation experts say the pilot made.
Why is this happening?
This typically happens when the pilot gets overworked and they're overwhelmed and there's too many things happening in the cockpit. And as a result, they don't make safe decisions. And you can really group almost all these crashes together into pilot error. You see, these smaller planes, they lack what's called envelope protection.
The principle was simple. A pilot pushing his stick or rudder pedal sent a command to a digital computer. The computer would flash signals through wires instead of pulleys and pivots to move the plane's flight control surfaces. It was a concept that few in the industry were prepared to consider.
Well, the reason that we can't use a digital computer is that there is no digital computer reliable enough to depend on for human safety and for the safety of an airplane. One of the NASA officials was Neil Armstrong, and he said, well, I just happened to have flown to the moon and back on digital fly-by-wire.
Electronic fly-by-wire controls
opened the way to an entirely new computer-aided safety feature, usually known as flight envelope protection,
allowing the flight control system to stabilize or to provide the ability for the pilot to control the airplane.
Wires can be routed through an aircraft much more easily than the maze of push rods, pulleys, and cables used in the past. Electronic controls are simpler, smaller, and lighter. They could then make it available for the aircraft industry to use.
The less for the pilot to do, the better.
Every day, an average of 5 airplanes are taking off or landing.
For decades now, only giant companies could build new airplanes. The regulations made modern technology almost impossible to certify, even though that technology could prevent deadly accidents. So almost a decade ago, the FAA started working on something new, a modernized rule set that would finally allow safer, more advanced technologies into small aircraft. Those rules were called MOSAIC.
So for too long, our rules have been outdated, holding back our pilots, our builders, and our innovators. It's been over 20 years since this rule has been updated, and by the way, a lot has changed in the last 20 years, and so that's why we're excited to be here today.
In other words, the FAA just opened the door for the future of flight. This made me think, could we build a personal airplane that was 10 times safer and so intuitive that you could learn to fly it in a single day?
If you really want to make the GA safer, I really think you need to focus on what the root cause of this. And you need to focus on building a machine that really doesn't allow the pilot to make mistakes.
What if we tried to build an airplane that was immune to human error?
Hey man, how's it going?
Hey Greg, how are you?
Good. Were you able to put those numbers together for me?
Yeah, so I talked to the composite shop and I've run the numbers for the engineering hours, and it seems like to continue forward with the Skytron design, it's going to cost about $20 million.
Well, before you can ever build an airplane, you have to design its configuration. And that starts with defining a crystal clear mission. We explore dozens and dozens of different configurations, different wings and fuselages and engine placements, testing each one against our safety, speed, cost, range, and manufacturability targets. This is where aircraft are truly born. Once you know the mission, one of the first major decisions is propulsion. Should we go electric? Should we try to do a turboprop or a jet? The only propulsion system that meets all of our targets is twin piston engines. We're going to be using the Rotax 916. It's a very modern 160 horsepower engine in an incredibly light and efficient package. It's turbocharged for strong high altitude performance and features full FADEC.
FADEC stands for Full Authority Digital Engine Controls. It's a way to communicate with the engine. So the engine is all hardware. So what the FADEC controller allows you to do is interface to the software with the rest of your system.
Which you can think of as giving you the same kind of smart, computer-controlled management that you'd expect in a modern car. Every choice is a trade-off. A bigger wing lowers the stall speed, but it adds drag. A wider
cabin is more comfortable, but it bulges the fuselage, which hurts your efficiency. Chapter 5, Structural Trade-offs and Relationships.
For us, it's simple. It seats 4 adults, cruises at 200 miles an hour, 1,000 miles of range, affordable to operate, safe by default, and you can learn to fly it in a single day. The first clean sheet personal airplane that is engineered to be default safe, even if the human pilot makes a mistake. Every control input goes through advanced flight computers that check whether or not what you're asking is safe. If you try to stall or overspeed the airplane, it simply refuses. If you get disoriented and turn towards terrain, it overrides you and guides you to safety. Lose an engine? The remaining engine will fly you safely to an airport. Anyone can learn to fly in just days. Flying has always inspired wonder, but for too long it's demanded too much. It's been too risky and too complex, too inaccessible. This really is the dawn of a new era in personal aviation, where freedom, safety, and simplicity finally share the same cockpit. A safer sky, a smarter airplane, a future where anyone can rise above the clouds.